So this is my final video for 3-moment equations, no? So we're going to solve another problem, pero this time we have a fixed support, no? So ano ang dapat natin gawin kapag may fixed support tayo, no? Fixed end rather, no? Kasi we can assume that every internal support are fixed, no? Pero sa on one or both ends of the beam, paano kung may fixed support tayo, no? So let's start. So let's consider this problem, no? You are to determine the reactions assuming that EI is constant. Okay, no? So you are given a fixed beam at a continuous beam with fixed support at A, no? And an overhang at point D. Okay, no? So since this is a fixed support, no, we can split that, no? We can convert your fixed support into two imaginary supports, no? So let's say we have an imaginary support A prime, no, at a distance, no, very small distance from point A. So therefore your point A now will become an internal support, no, and the length, no, so length from A prime to A is just 0, no, kasi we assume that this is just a very small distance, no. Okay, next we have your point B now, no. Okay, no, so we have your point B. This is equal to 225 kilonewton, no, so 3 meters. Okay, and then we have at point C. Okay, and then we have, let's also place the uniformly distributed load, 30 kilonewton per meter. Okay, no, so A, B, C. Okay, no, so let's consider let's go back again, no, from our general formula for the 3-moment equations, no. No, so MA, no, times L1 over E1 I1 plus 2MB times L1 over E1 I1, no, plus L2 over E2 I2 plus MC times L2 over E2 I2, no, plus 6 area 1, no, first moment of area over L1 E1 I1 plus 6 area 2, no, first moment of area, no, L2 E2 I2, no, is equal to 6 multiplied by H1 over L1 plus H2 over L2, no. So from that we can also say that EI is constant, so E1 I1 is equal to E2 I2. Okay, that is our first assumption. This is also equal to EI. No? Next, since they are all supports, no, and they don't have final deflection, we assume that all supports will not undergo any permanent deformation. No, so we can say that your H1 is equal to H2 is equal to 0. No, so we can cancel out this one. So H1 H2 is equal to 0. E1 I1 E2 I2 are all constant. No, so therefore our final formula now will become MA, no, multiplied by L1 plus 2MB times L1 plus L2 plus MC times L2 plus 6, no, 6 times A1A over L, no, plus 6 A2B over L, this is L1, this is L2, is equal to 0. Okay, no, so this will be our working equation. This is our general working equation, no? So next thing that we need to do is to choose which 3 points are we going to form, no? So anong tatlong points yung gagawa natin ng equation, no? So meron tayong A prime, A at saka B, no? Meron din tayong A, B at saka C, no? Since we should only do 3 moment equations on all supports, no? So therefore 3 moment equation for A prime AB, no? So M A prime times 0 plus 2MA times 0 plus L2, no? So L1 is 0, L2 is 6 plus MB times 6 plus 6 times area of A prime A, no, times A, no? Ang ibig sabihin niyan, no, ang centroid natin shall be measured from the left over L1, which is equal to, no, L1 natin is equal to 0. Okay, no? So plus 6A2, no, 6A2B, no, 6A2B, no, over L2, no? So rather A B, no, times B over L2, which is equal to 6, no, equal to 0, no? So we found out also na since we don't have any load acting from A prime to A, no, we can say that this is equal to 0. So therefore 2MA times 6 plus MB times 6 plus 6 times area AB times its centroid, no, from the right over 6 equal to 0. Okay, so our final equation will now become 12MA, no, plus 6MB, okay, no, plus, no, we cancel out this one, area AB times centroid measured from the right equal to 0. This is your equation 1, no? So We have one equation, no, and two unknowns. So we can form another equation, three moment equations for ABC. Okay, we can form three moment equations for a span ABC, A, B, C. No, so no, from that A, B, and C. A, B, and C. Okay, so three moment equation for A, B, and C. Okay, MA times 6 plus 2 MB times 6 plus 9 plus MC times 9 plus 6 area AB times A over 6 plus 6 area BC times B, no, measured from the right, over 9 is equal to 0. Okay, no, so by that we can uh, we combine everything, no, so 6MA, no, plus, no, 6 plus 9, 15 times 2, 30MB plus 9MC, no, plus 6 A area AB times A over 6 plus 6 of area BC times B over 9 is equal to 0. Okay, so next, no, we found out na we have three unknowns. Pero wait, there's more. No, you have to remember na at point C we have an overhang, no? So therefore we can just isolate your C, no? We can just isolate your span AC going to D, no? This is assumed to be 3 meters, no? Okay? No? And then this is 30 kilonewton per meter and this is 3 meters, no? So dahil overhang yan, no, we can just say that, diba, we have a moment at C equal to 30 times 3 times 1.5. 30 times 3 times 1.5. This is equal to 135 kilonewton meter. And we can also say, no, we can also say that we have a reaction here of, no, so 1 so of 30 times 3, this is equal to 90, no, 90 kilonewton, no. Okay, no, so from here, no, we have your MC. We're going to use it here on the three moment equation for ABC. Pero mamaya before we do that, this is your equation 2 now, no? Before we do that, let's try to solve for the first moment of area first of span AB and span BC. Okay, no? So how are we going to do that? No, we do it, we isolate every span and every member, no? So we isolate every span and every member, no? Okay, no, so let's say this is your A prime, no? A prime, no? So this is equal to A, this is A, the length is 0 meters, no? So, and then your A, no? Your support at A, no? This is your A going to B, no? And we have our support at B going to C, no? Assuming that they are not on scale, no? Rather, let me just draw this again, no? No? Okay. This is your A prime going to A, no? So this is your support at A. This is your A going to B. This is your support at B. This is your B going to C. This is B going to C. B, C. This is your support at C. And this is your overhang, no? So C. Okay, next this one. B going to C. This is 9 meters. Okay, this is 30 kilonewton per meter. This is 30 kilonewton per meter. Okay, and we have a concentrated load here of 225 kilonewton. This is 3 meters, 3 meters. Okay, no? So that is your beam now, no? And we sketch the moment diagram of span, no? So we can neglect your A prime A, no? So we can just consider this span AB, no? So if we just divide it by 2, 225 divided by 2. Now we can just say that they are equal to 112.5. 112.5. 112.5. Okay, this one 30 times 9. We divide it again by 2. This is equal to 135. This is equal to 135. Okay. Next, at C going to D, no? So we have the 90 kilonewton upward here, no? So 90, no? And the moment of 135. But let's neglect that first, no? So ang mahalaga sa atin is we assume that each span are simply supported beam, no? So wala pa yung moment. Okay? So the moment again, no, kagaya nung we have to make sure that when computing area and centroid, no, we need to make sure that they are easy to compute, no? So they are both madaling computein, no? So dahil nasa gitna ang we can do the conventional moment diagram, or we can just use by parts, no? So I decided to do by parts, no, at AB, no? So at AB, no, at AB, no, I'm going to measure it from the left, no? So look at the equation, no? So yung span AB, we need both the centroid from the left and from the right, no? Kung dahil yung load naman natin, yung concentrated load natin nasa gitna, so regardless kung mag from the left tayo tsaka from the right, no, pareho lang ang lalabas diyan, no? Pero kung kunyari wala sa gitna itong concentrated load na to, tsaka mo lang iisa-isahin yan, na you will draw a by parts from the left or by parts from the right, or you can try to use the other means of determining the moment diagram, no? So dito dahil nasa gitna naman siya, regardless kung from the left or from the right siya, no, pareho lang ang lalabas, no? So assume na lang natin na from the left siya. So So this is equal to 112.5. No? Meron tayo ditong load. 112.5 times 6. No? This is equal to 675. And then 225 times 3. This is negative 675 also. Negative 675. Okay? For this one naman, no? As for this one, we do the same thing, no? Pero from the right, no? This is a uniform load, no? Kaya the weight is just the same, no? Kung from the left man or from the right ako mag moment diagram. So therefore, assume na to the right ako magka-clamp, no? So 135 times 9. This is equal to 1,201, 1215. 1215. No? And due to the concentrated load, due to the uniformly distributed load, no? 30 times 9 times 4.5, this is equal to negative 1,215 as well. Okay? So therefore, your area AB, no, times A, no, which is also equal to area AB times B is equal to, no, 1/2 times 675 times 6 over 3 plus 1/2 negative 675 times 3 times 3 over 3. Okay, next. Let's compute it later, no? So area BC, no, times A, which is also equal to area BC times B, equal to, no, 1/2 times 1,215 times 9 over 3, no, plus 1/2 negative 1,215 times 9 over 3. Okay, no? So we compute them individually. 1/2 times 675 times 6 over 3 plus 1/2 times negative 675 times 3 over 3. This is just equal to 6,075 over 2. No, this is equal to as naman 1/2 times 1215 times 9 times 1/2 times 1215 times 9 over 3 plus 1/2 times negative 1215 times 9 over 3. No, mali, rather, this is wrong, no? So 1/3, this is 1/4, no? Okay, kasi this is already a second degree curve. 1/3. This is equal to 32,805 over 4. Okay? No? So that would be it. Let me recheck it again. 1/2 times 675 times 6 over 3 plus 1/2 times negative 675 times 3 over 3. Both are still the same. 1/2 times 1215 times 9 times 9 over 3 minus or plus 1/3 times negative 1215 times 9 times 9 over 3. Okay, they are still the same. No? Okay, now we have now your first moment of area for span AB. We have now your first moment of area for span BC. We can now use them both, no, on the three moment equation, no. So balikan natin yung three moment equation kanina. MA times 6, no, or rather 12MA plus 6MB plus area AB times B is equal to 0. Next, 6MA plus 30MB plus 9MC plus 6 over 6. No? So, area AB times A plus 2/3 of area BC times B is equal to 0. We input all the values that we have, no? Your MC is equal to 135 kilonewton meter, no? So from here, but what should be the sign convention that we're going to use, no? So let's assume na the other side is fixed, no? What is the moment doing to the beam, to the span, no? 'Di ba? Pinapasimangot niya yung beam mo. So therefore, we're going to use negative sign, no, at M sub C, no? So 6MA, this 6MA plus 30MB plus 9 times negative 135 plus area AB times A, 6075 over 2 plus 2/3 times 32805 over 4, no, which is equal to 0. No? So next equation naman, we use 12MA, no? 12MA plus 6MB plus area AB times B equal to, area AB times B is equal to, no, 6075 over 2 equal to 0. Okay, we combine them all, no? This is equation 1, equation 2. Negative 9 times 135 plus 6075 over 2 plus 2/3 of 32805 over 4. This is, if we combine them, no, 6MA plus 30MB, no, plus 7290 is equal to 0, no. So 12MA plus 6MB plus 6075 over 2 is equal to 0. Equation 1. Equation 2, using mode 5.1 from my calculator, I was able to get, no, 7290, 12MA 6 negative 6075 divided by 2. MA is equal to negative 146.25 kilonewton meter. MB is equal to negative 213.75 kilonewton meter. We now have your internal moments, no? So we're going to solve now for the reactions. Now that we have your internal moments, no, let's proceed with determining the reactions, no. So for the reactions, no, we are going to separate it into two parts, no. First, the part na we retain all the loads and we assume that every span are simply supported beams, no. So ang reaction nito, I guess this is equal to, no, we solve this, no, 225 divided by 2. So this is equal to 112.5, 112.5, no. Okay, next, no, this one, no, 30 times 9 divided by 2 again, this is equal to 135, 135, no. And then this is equal to, no, 30 times 3, no, this is equal to 90, no, like what we've solved before, no. If this is equal to 112.5, no, na upward, no, we can say that this is 112.5 downward. This is 135 upward, we can say that this is 135 downward. And then we can conclude that the support reaction here, no, due to the loads, no, assuming that they are all simply supported, 112.5, no, plus 135, this is equal to 247.5. Next, at point, this is at point A, no, so we have 112.5. At point B, we have 247.5. Next, at point C, this is upward 135, this is downward 135, this is upward 90, this is downward 90. So therefore, we can say that this is equal to 135 plus 90, 135 plus 90, 225. Next, we determine the reactions due to the internal moments that we're able to solve, no. So moment at C is equal to negative 135, no. So since it's making your beam frown, no, so we can say that this is equal to 135. 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 Okay, no? This is A. This is B. B. C. C. Okay, this is 135. So moment at B is equal to negative 213.75. This is equal to 213.75. This is equal to 213.75. 213.75. 213.75. Moment at A is equal to 146.25. Okay. So next, to determine the moment, no, determine the reactions due to the moment, no, we can do, no. So since no, so we can just try to we can solve, no, using we can solve using the principles of what we've learned from engineering mechanics. First, at span AB, no? So at span AB, we're going to combine both of this moment, no? So pag pinagsama natin yung 146 na counterclockwise, negative 146.25 plus 213.75 na clockwise, this is equal to, meron pa tayong clockwise na 67.5, no? So therefore, no, kapag ka nag-moment tayo at B, if we do summation of moment at B, and meron tayong clockwise na 67.5, now we can say na ang reaction at A natin will be equal to, will be downward, no? So 67.5 divided by 6, this is equal to 11.25. Next, kung downward na 11.25 to, we can say that this is upward na 11.25, no? So upward yan, so therefore this is also downward na 11.25. Okay, next, no? Next thing that we need to do, no? Next thing that we need to do is to consider naman, no, span BC, no? So we combine these two again. So negative 213.75 plus 135, no, which is clockwise, no? We have a counterclockwise resultant moment of negative of 78.75. And syempre at point C, no, if our resulting moment is a counterclockwise moment, dapat clockwise ang kokontra sa kanya. So therefore at point C, we can say that it is downward, no? At point B, upward naman siya, no? So 78.75 we divide it by 9, which is equal to 8.75, no? This is equal to 8.75. Now, if we have an 8.75 upward moment, upward shear here, we can say that this is 8.75 also. This is downward, we can say that this is upward, 8.75. Okay, next, no? How are we going to consider this naman, no? So next thing that we need to do is we can do, no, so at C, no, so nga pala, since from the previous figure, I decided to assume that this overhang is already a fixed support, no, and all of its reactions are there na already, no. I can just neglect the reaction on this span, no. So ito na lang ang natitira dyan, no? So the 8.75 kilonewton. If that is upward, no, we can say this is downward, 8.75 kilonewton. We combine everything, no? So let's draw this first. Let me draw, no? So 225 kilonewton, no? We have a uniformly distributed load of 30 30 kilonewton per meter. Okay? This is equal to 3 meter, 3 meter, 9 meter, and 3 meters. No? Let's combine all together all the reactions at A. At A, we have an upward load of 112.5, 112.5, and a downward load of 11.25 minus 11.25. That is equal to 101.25. And the moment of 146.25. Next, we have at point B, no? We have, no? So let's combine this first. This is equal to 11.25 plus 8.75. This is equal to 20, no? And therefore, we have a 247.5 upward load plus 20. This is equal to 267.5. Next, we have a 22.5 upward load. Further, 225. We subtract it by 875. No, so 225 minus 8.75. This is equal to 216.25. No, so we check it using summation of forces and summation of moment. Summation of forces 101.25 plus 267.5 plus 216.75, no? Okay, 101.25 plus 267.5 plus 216.25 rather. This is equal to, no? Minus 225 minus 30 times 12. That is equal to 0. Those are all equal to 0. And if we do summation of moment at A, no? Summation of moment at A, no, is equal to negative 146.25 plus 225 times 3 plus 267.5 times 6 plus 216.75 times 6 plus 915, no? Minus negative 146.25 minus 225 times 3, no? Plus 200, let me repeat that again. Negative 146.25 the moment plus 225 times 3 minus 267.5 times 6 plus 216.75 times 15 minus rather plus 30 times 12 times 6 plus 6, no? So, let me repeat that again, no? Okay, so 146, no? So negative 146.25 plus 225 times 3 minus 267.5 times 6 minus 216.25 times 15 plus 30 times 12 times 6 plus 6 equal to 0. So therefore, everything that we've computed are all correct. And that ends our video. Uh, and also that ends our topic concerning three moment equations. No, so we're going to discuss either slope deflection method, no, so that is another method, and the last part, which is the moment distribution method, no, for applicable for both beams and frames. No, so if you have any questions regarding this topic, no, uh, leave your comments below, or continue to, or leave me a message. No, so my social media accounts are all open, no, and or use the Blackboard, no, for messaging, no, and also, no, uh, for more updates, no, always check your Blackboard and like and subscribe to this channel, no. So see you next video.